Okay, then welcome to my talk about PMD and the journey to PMD 7, the new major version. First, one short note about myself. Here you can see my GitHub profile. I'm developing software for a while, many years now, mostly in Java. I had some project done also in embedded. I'm one of the maintainers of PMD, and I'm doing this since 2012, so now 12 years. During that, I'm also got commit rights for Maven, because I kept the PMD plugin up to date for a while, so they thought it would be good if I have commit permissions. There are some other projects. They are all also open source that I'm involved in. Since 2018, I'm working here in Munich at Microdoc. And that's all from me now. So what I'm going to talk today is, I basically have three main goals. First, of course, I want to promote PMD, that it is better known. Then, the basics, how to use it, and also some highlights, what has changed with PMD 7. Then I want to look a little bit back about the process towards PMD 7. The challenges we faced and what we can learn from that. And as last, a little bit look into the future, what comes next for PMD. What I won't talk about today is more in-depth knowledge about PMD, like extending PMD, writing own rules, customizing it. That could be another talk, if there is interest. So let's start with what is PMD. This is, first of all, a static code analyzer, but the interesting thing is that it is now for different languages, not only for Java. It finds mistakes, problematic code, something that looks odd or could be improved in your projects. Multiple languages, as I said. It is rule-based, so every problem that PMD can detect is based on a rule, and you can write your own rules. So that's one good thing. You can customize it. There are two ways to customize it, to write your own rules in Java. So PMD itself is written in Java. But there is the other possibility to write rules in an XPath expression. So you can query basically your source code and find the problematic patterns. And to help in developing these XPath-based rules, we have also an application called the Rule Designer, which shows you how the source code looks like, and you can try out the XPath queries there. In total, there are more than 400 rules that we have, and we support more than 10 languages now. You see here also the logo of PMD. That's also one new thing of PMD 7, but it's already a while ago when we decided to take this new logo. We are on GitHub, of course. Then the other thing that's often overseen from PMD, and I also often forget, is there's another component. This is the copy-paste detection. That's duplicated code detector. And this even supports more languages it's based on some other technology that you don't need to parse the language completely, so it's a little bit easier to support other languages. PMD itself is officially not an abbreviation, or it has no meaning in itself, it's just PMD. But I found one clue in the source code, and it probably means project mistake detector. That's in one package, HTML file back a couple of years.
What it means probably means detector. PMD.
Yeah, could be. We have on the documentation page a site which explains different meanings, possible meanings of PMD. But yeah, right. It's an open source project, and it's actually the first release was in 2002, so it's now 22 years old. It's under the BSD license. Yeah, we are 3 maintainers working on this project, and we have a couple of occasionally contributors. But you will learn more now in the next slides what's all behind this. But first, some simple examples. How can it help you for your project? So some basic examples what it can detect. In this code, the developer tried to do something when S would be null, but there is a problem. If it is really null, you get here a null pointer exception, and this simple cases where the Boolean operators are just in the wrong, or the wrong operators used. We can detect there's a rule for this, that's broken null check, and this is in the error-prone category. Another example is this one. As you mentioned, exception handling before. That's also an interesting one. I've actually not seen this, but it's possible. It's still possible in Java. You can return from a finally block. And the problem is that every exception occurring before is just discarded. You don't see anything about this. That's why I added this commented out print stack trace to actually see there is something. That's return from finally block. Also in the error-prone category. This is one rule that detects also something, basically.
Storage.
Right, so you have an immutable object like string. So replace doesn't change the string but returns a new one. And this rule currently detects it for strings, and big decimal are similar. When you do some operations on this, it always creates a new instance. Right. This one is now in a different category. It's suggesting for this simple rule, for this simple for loop, it's suggesting that you can write it in a for each loop. Then you get rid of the index and you can't mess with the index variable.
You can use a stream, I guess.
Yeah. So that's, of course, a very simple example. So that's in a different category, that's in best practices. And that's the last example. That's in the category code style. Here it's about boxing. And you might prefer that you don't, if you use value of, you get a boxed integer, which is then, as you store it in a primitive type, it's automatically unboxed. You can avoid this round trip and just use parseInt. And yeah, that's just a different style. It probably has no real implication performance-wise or so. Right, as you've seen, there are different categories in where we sorted in the rules. In total, we have 7 categories, and we have a few for performance and for security, not so many. Most are in best practices, error-prone code style. And in total, we have, we have in total 400 rules, but for Java, we have 270 rules that you can use. And these are very many. So you wouldn't use all at once. And some rules also contradict each other, so you can't use everything at the same time. The way to go is you create an own rule set and pick the rules that are useful for you. And when you have an own rule set, you also can configure the rules. Some rules have properties, so you can adjust them to your needs. Right, then next up is how can you use it? PMD itself is written in Java, so you need, of course, Java to run it. And one simple way is just to download the binary distribution and unzip it and run it as a command line interface tool. But for Java projects, it's usually easier just to use your build tools you have anyway and use Maven, a Maven plugin, Gradle plugin, or Ant plugin. These are just the most common ones. We have support for some other more uncommon build tools, I would say. Well, actually, it's not, well, they support also PMD. And we have a GitHub repository with some starter projects to get you started, where you can just look at how you edit. As an example, I have here the Maven configuration. It looks like this. You just add the Maven PMD plugin. And with 2 goals, or at least 1 goal, the first goal will then execute PMD and verify that you have no violations. If there are violations, the build is broken. So you can use it as a simple quality gate. And you can, as you see here with CPD check, also run the copy-paste detector. With here, you don't see any configuration. It uses a default configuration. The PMD plugin has a simple default rule set with some common rules. But as I said before, you usually want to have your own rule set that fits your project.
This is even a default Maven plugin. You don't need to specify the group ID.
This is right. That's the official from the Maven team. The default group ID, I left it out. Yeah, so that's really the minimal configuration. Apart from the build tools, where it is integrated when you build your project, you can also run it earlier. So there are plugins for different IDEs, like Eclipse. There are actually 2 plugins. For IntelliJ there's a plugin. For VS Code are I think a couple of plugins. And if this is not enough, you can also use some cloud services or CI plugins. So if you use Jenkins, Jenkins has a plugin to visualize the PMD results. and this can also display a history about across the different builds, so that you see whether you have more violations or less, whether your quality basically improves, if you will. There's a GitHub action, and there are cloud services. These usually promise that they do an automatic code review, and often these are GitHub apps that you can install in your repository. And so GitHub apps, they usually are also executed when a new pull request is created, and they comment the pull request, and they under the hood also use PMD often. So there are a couple of services that actually use PMD. Like, for example, this Salesforce Code Analyzer is one tool. We will see later on that's not a Java language, but they also use PMD now. Next is, how can you extend PMD? So it's customizable. As I mentioned at the beginning, you can write your own rules if the 270 rules are not enough. But usually you want to write rules, for example, if you have a custom framework that you want to ensure that you use it correctly or stuff like that, then you can easily write your own rules and check this. We have this rule designer. I'll show in the next slide a screenshot of this. But apart from the rules, where we have a very good tutorial, step-by-step guide to create your own rule, you can also extend PMD to add support for a new language. This is a bit more involved in PMD. And of course, new features are also possible to add. We will see at the end what could be done in the future with PMD. So here's the rule designer. This is basically how it looks like. In the middle you have the source code. On the right side you have the abstract syntax tree with all the nodes, and down below you have the XPath query. In this example, so I'll search all method calls for a specific method, so all method calls to string replace. And I further narrow it down that I only want to see the calls that have foo as an argument. And that's just an example how you can access attributes. And the other important thing here is that it's not an assignment expression. So that's basically the problem with the immutable objects. Right. Then the question is, how popular is PMD? And we are an open source project, so nobody needs to register when someone downloads a copy. We also don't have any telemetry built in, so we don't know who uses it, when it's used, how often, for which projects. That all would be interesting to know. You can look at the download counts, like GitHub provides for the releases download counts, or Maven Central also has download counts you can see. But in CI builds, it's often the case that the dependencies are downloaded sometimes for every build. So the download count is basically just, you can see it's used, but but not for how many projects. We of course get bug reports and feature requests, so we know that at least someone is using it. That's good to know. But the other interesting thing is that it is integrated into other tools. And as I mentioned, like Salesforce Code Analyzer, That's for the Salesforce platform. So Salesforce created an own language, and they have an also static analyzer tool that checks their code, and under the hood they use PMD. But right, we are on GitHub. So GitHub is the new social network for developers now. You can like projects and stare it, so you can have a look at the stars. And if you look at this, so this looks good, always growing. We are now at 4,800 stars. So at least it's still rising. But there's another, so this is from StartChart, which just queries GitHub API and figures out when the users start the repository. But there's another page which provides different analysis on the GitHub data, and this is OSS Insight.io. That's actually a demo page for a big database, because they do real-life GitHub events into a database and do a query on these billions of rows. And they look at who stars, and you can see a couple of companies. So there's Alibaba, Google, Microsoft, Salesforce, ByteDance, Tencent, and a couple of independent. So all we can say, it seems to be used by many, but we don't really know exactly how. Right now, to the new features or highlights or what has changed in PMD 7, I have 4 topics I want to present a little bit more in depth. This is first what has changed on the Java language support, and the changes on the Apex language support. That's the Salesforce stuff. Then we had some changes on the API, because you can consider PMD itself as a framework for static code analysis, as we support a couple of languages, and you can add support for a new language. You can even develop it in parallel. It doesn't need to be in the same repository. It can just be a plugin library. And as we parse code, we also generate parsers, and there we added now better or full support for Antler. But first, let's have a look at what has changed on the Java side. So the PMD is quite old, so the grammar also has grown over the time. And this time we took some time to clean it up and align it more to what is actually written in the Java language specification, so that we also can parse all the edge cases, like this with the annotations on the array elements, and actually figure later on out where the annotations placed, because it's important to know where. And we have added new nodes. They are more similar to the language specification, like variable access and method call. Before, it was really difficult to figure out whether some primary prefix and suffix is actually a method call, because it has arguments later on. So now it's clear it's an own node, and you can it's much simpler to write rules around this. Of course, changing the grammar, the abstract syntax tree, means that all the rules need to be adapted. So that's a breaking change, and that was also the one task that we did in PMD 7. So we basically have redone also all the rules. One moment. Right, type resolution is another topic that's completely redone. That's needed if you want to see or want to query what are the supertypes of some variable you have defined in your code and check some kinds, or if you want to limit your rule to check only for one specific type, you need to know, you need to query the types. That's the type resolution. In PMD 6, we actually did it that way that we loaded the classes via class loader and used reflection to figure out all this stuff. That means you needed to run PMD with the same Java runtime as you have compiled your project. This is now different, so we use now only ASM and read the bytecode. And basically you can now run PMD in Java 8 and analyze code for Java 21. And yeah, one interesting thing we figured out at the end is when we reviewed all the open bugs, that during this rework of the Java language module, about 30% of the issues fixed that we have fixed for PMD 7 were not directly planned, so they were incidentally fixed because the abstract syntax tree now better fits what we need, and the rules work better now. Right, then for the Apex language support, that's an interesting thing. So in Java, we did some breaking changes because we changed the abstract syntax tree. In the Apex language module, there's something different. So when we started supporting the Apex language in PMD, we added some binary blob, which contained the parser as a black box from Salesforce. They had some language server for VS Code. And we used that to parse the code, but we never knew when we need to update it, what has changed. So that's a bit of a mess. And now we switched to an Antler grammar. That's now also that's open source. It was before also open source, but now Salesforce tends to, or as far as I understood, as far as I understood, they probably plan to actually use that in the future. So the GitHub space Apex DevTools is more or less officially supported by Salesforce. And so at one point, some guys from Google came to us and said they can't use PMD because we have this binary thing and they are not allowed to use anything that uses binaries. And they would like to create some translation layer to use this grammar. And so they did it. That's what some Google guys written that Summit asked, that basically translates what comes out of the Antler parser into an abstract syntax tree that looks basically exactly the same like the old binary blob produced. And that means we changed the complete parser engine under the hood, but the rules could stay the same. And yeah, as I mentioned now, so this PMD is one engine in the Salesforce code analyzer that they provide for their Salesforce platform to check their code. There's also ESLint included and PMD. So that was mostly or basically a compatible change. Now again, an incompatible change, a breaking change is what we changed in the API. So of course we did some cleanup as has also grown over the years. What classes and interfaces you can call to run PMD and integrate with PMD. And we now tried to separate more clearly what is implementation and what is public. And we hope that we now can easier change something in PMD without breaking all the clients. Yeah, there is one interesting new thing. There's also new RP, node stream RP. That's an alternative to the visitor pattern. So when you implement a rule, you currently write a visitor that visits the abstract syntax tree to find the interesting parts. You can also use now node streams that makes it easier to traverse, and you don't need to check for nulls. It's very similar to the stream API from Java. And it's also lazily evaluated. So if it doesn't find any method declarations, then it stops already there. The last big change in PMD7 is that we now fully support Antler. For what when you add a new language in PMD, before it was only Java CC that we supported. So you have a grammar in Java CC and then we call it to generate the parser and the nodes of the syntax tree. Now you can also use a grammar written for Antler. And this integrates with all the infrastructure that PMD provides. So you can write rules and immediately also use XPath expressions to query this. With that, we got now support for Swift and Kotlin, but that's not really ready to use because so we have opportunities now that it's easier to add new language with Antler grammar because grammars for Antler are usually more available than Java CC. But there are more challenges we figured out because Antler by default only produces a parse tree, and you need some effort to actually convert this into a more abstract syntax tree. That's basically what the Google guys did with the Summit AST project. They translated this into an abstract syntax tree. So there is still some work to do. And here you can read more and more in detail. As this is a major version change and with breaking changes, we have also a migration guide. So if you come from PMD6. Right, now the journey. So the question is now, how long did it take from PMD6 to PMD7? And any guesses?
5 years.
Not bad, not bad.
Like between Java 6 and Java 7.
Yeah. No, it's actually a little bit more than 5. So I've looked it up, how it works out. So PMD6 was released in the beginning of 2018, and half a year later we created a branch for PMD7 and started basically fresh, enthusiastic new version. And this is, the first part around 5 years went so on. So we developed in a separate branch, and meanwhile we did regular merges from the main branch to the PMD7 branch, And from the main branch, we kept on releasing new versions for PMD6 with bug fixes and new features when there was some contribution. And yeah, at some point last year, I said, we need to do something that could go on forever. Either, so I started to look at what is really necessary for PMD7 and create basically a new plan, what is still left to do, and then we merged back the branch to the main branch, but still then it took another year to actually finalize it. So it's quite a long time. In the last year we also created then release candidates. Yeah, basically for the first time after 5 years. We of course had some snapshot builds from the branch, but who uses snapshots? Now I looked up some statistics. So as I said already, it's 6 years ago when we started PMD7 development on the branch. We did many releases on the main branch. These were actually 51 minor releases. We have a monthly release cycle, so every month we release what is there. So we kept this for PMD6. We made a break now, but we are back now at the monthly release cycle. Yeah, we have lots of issues and pull requests that went into PMD7, and a lot of commits, as you can see, and these I've also looked this up with some Git log queries. So these are actually only 46 commit authors. But at least it's not only V3 maintainers. Then another thing I looked up is, because I was interested, is PMD now bigger than PMD6 or smaller? And there's some interesting insight, because if you only look at the Java code, you actually see that PMD7 has less Java code than PMD6. If you combine Java and Kotlin, it's about the same lines of code. And yeah, maybe we did much better with less code. So, but while researching this, I found another interesting analysis, and I want to show here. That's this Git of Theseus. That's an old blog post about the half-life of code. So that's actually a more philosophical question. It's the ship of Theseus where this comes from. You have a ship, and over time you repair the ship, replace parts of it, and after a couple of years you have replaced every single part of it, and in the end, is it still the same or not? You don't know. And this is what this analysis tries to figure out a bit. Is the code, for example, the code from 2002 still somewhere in the repository? It's maybe it's very, very little lines, very less. Yeah.
Breaking line in the center.
So there are some interruptions in there. So PMD started on SourceForge, so it was Subversion at the beginning. But when we migrated to Git, we migrated the complete history. So you have here the complete history. It's also on GitHub, so you can search back in time. And this big part in the middle is where we moved out the parts from the monorepo two separate repositories. So this is where many things have been moved out. There are two other breaks. This is in 2018 around. This is probably PMD 6 release, and this in the end is PMD 7 merge probably. Yeah, that's just some toy analysis, but in the end, so this guy with the half-life of code ran this for a couple of repositories, and one thing that he noticed is one constant is that the code always grows. So it always grows. Right, then back to some more serious topics now, the challenges we faced. So you can imagine 6 years are a long time, so you need motivation and perseverance to actually bring it to the end and not say stop and throw it away. And yeah, as always, the last part is still hard. It still took 1 year to finalize it. In general, yeah, major releases takes long. This is actually, I looked it up, the longest, but the release before, I think, was also 5 years of PMD, and we have now 22 years. So in average, we have now almost every 3 years a major release. But we should think about this in the future, whether it really needs to go on that way. Yeah, the other challenge is we had the parallel development. So we created a separate branch at the beginning, and we did basically develop 2 versions in parallel. That was time consuming, I would say, at least. We had big plans and many ideas at the beginning, so maybe we also had too ambitious plans, but as I said, yeah, we revised the plans, and plans are there to be changed. So we have also on GitHub a milestone for 7.x. So these are all the ideas, issues we moved out. Another challenge is over the years to keep track of the progress. What is actually already completely done, what is half done, what is missing, because it's also spread over a couple of places. Right, then what else? The new branch might look great at the beginning, because you can start fresh, don't need to think about anything. But we from after some time, the merging was more expensive. So we merged regularly from the main branch back to the 7 branch to get the bug fixes. And actually, I think that's also why we somehow hesitated probably to do some bigger refactorings, remove old classes or rename, move stuff around, because then it would be a hell to merge. And the other thing is missing feedback. So we had a branch and created snapshot builds from this branch, but we never released a release candidate. We only did this after we merged back the branch. So yeah, basically no feedback. We had some massive pull requests. That's one thing. Sometimes if you change one thing, like a central API, you need to adjust every module. So we have 22 languages. If you change something there, you need to change all the users of this API. And when you do a breaking change, you need to have a look at the ecosystem that you can. Well, if you release PMD 7 and nobody can use it because the PMD plugin doesn't work, IntelliJ plugin doesn't work and so on. So you need to have a look for this. Right. And if there are no release candidates, they can't prepare for the update. Now some lessons learned. They are probably not so new, but nevertheless, these are the things that fit here in this example. So first thing is, if you don't have time to work on this constantly full time, you shouldn't do it in a branch that lives 6 years long. Short-lived branches are okay, but if you think you can't do it in a short time, you shouldn't do it in a separate branch. You need to do something different, some different way. At some point, we disabled tests to maybe move faster, but that means that the branch was basically not production ready because we don't know, does it work still or not? So there was that was one big thing that needed to be fixed, and it's just postponing. When you disable the test, it's just postponing. You anyway need to do it at some point. Then when you deprecate stuff, you have maybe great ideas. It should be done in a different way, the API. But you should only deprecate it if the new way is already there, ready to be used. Because if this other task is not done at all, then you can't deprecate it, because then you would lose functionality. And yeah, that's maybe one solution. Maybe we need to see whether this really works, that you try to do these bigger changes in smaller chunks, in more compatible chunks. It might take, well, I wanted to say it might take longer, but PMD 7 also took 6 years, so it's probably not an argument. But an argument for doing it in smaller chunks is that you can actually deliver it earlier, because you can either do a release candidate, or you can put it as an optional new API first and deliver it in a regular release. Yeah. So these are the lessons learned. Now the last part is the future. What is still left to do for PMD? There are, of course, still a couple of things. I have sorted it a little bit in two areas. One is the more boring one, which is about the project and stuff you need to do, and the other one is more the features. So first thing is future plans. I don't want to say it plans because that sounds like a promise. It's more ideas. We never know when it's done. So the first thing is compatibility. We have seen that it's important to have some compatibility, because it really takes some time until all the downstream consumers are up to date. So we have now some plugin enabled that checks it for us, so that we hopefully don't break it accidentally. We can still break it if we change something semantically. But yeah. And one funny thing is we upgraded with PMD 7 to Java 8. Isn't it fantastic? This was maybe 6 years ago, maybe still okay, but today it's with Java 23 now available. probably a reason alone to just to upgrade, make a major version.
Yeah, but it's a Java version which is still used a lot.
Right, it's still used a lot, and it still receives updates, so it's not deprecated yet, but yeah. Yeah, we hesitated also a little bit because it's Maven has now tool chains, so that's not a problem. But before Maven, the old Maven version, that was also a couple of years ago, needed to be run with Java 7, for example. Then you need to make sure that your plugin also runs with Java 7. And that's why PMD 6, for example, still uses or still is Java 7 compatible. Right. Then we have some tasks on the user documentation side. So what would be to improve is make it easier to get started with PMD. With 270 or more rules, it's very difficult to, or very time consuming to figure out which rules you want to use, which are useful for your project. So there is stuff to do. I've also mentioned here packaging. Currently we have one big package which supports everything that PMD can, but usually you only need, for example, for Java projects, you only need Java. You don't need the other languages. So we could do this in a bit different, and we also release everything at the same time, but many languages don't change, so they are unchanged. As we have now basically a stable API, we could actually split this more apart, these modules, and make the package smaller. It's basically a size issue. Right, the next thing is what I mentioned is more the what I think the boring side, the maintenance and project management stuff. Of course, fixing bugs triaging and stuff like that is always on the plate. But what we should do is improve the CI builds we use. We use GitHub Actions. We have a long history of different tools. Now we are on GitHub Actions. But they are currently one big job, and there's much automated already. But if something fails, like some service is not available, just resets the connection. It fails, and you need to look at the logs where it exactly failed, and so we could do this better, have more insight. And there is some developer docs, but not so many. So what would be nice is an up-to-date architectural overview, something like that. And we have a couple of pages with roadmap and future ideas. Now we have one slide more. That should be merged together and describe what is actually in scope of PMD's project and what is out of scope. And now to the more interesting thing, the features. What is maybe coming in the future. And the first part is, so you can write custom rules in Java and XPath expressions. Recently, someone tried it out to integrate JavaScript because he noticed that, or at least in his environment, they don't know XPath. It's too difficult. It's too... But JavaScript, they know. That's, yeah. So, and it's actually not that difficult to make this possible, then it's a bit easier to share the rules, because you don't need something compiled like if you have written it in Java. Another part is metrics. We have some matrix calculations that rules can use, like complexity matrix. This feature request goes more in the direction that PMD could be used to calculate metrics of a project, to get more insight about the project, how big it is, how many classes are there, what is the size of the classes in average, something like that. Right, this is also currently on discussion how we want to do it, because that would be now actually a different type of thing that PMD would do, not finding violations, but calculating metrics. Yeah, multi-file analysis is long discussed, and we postponed it again. Currently, PMD analyzes file by file. That's good because we can do it in parallel. But for some tasks, it would be interesting to have an overview of the complete project, especially if you want to do some usage analysis, if something is used somewhere in the project or not. Yeah. Similar to data flow and control flow. In Java, there are two rules actually that use some data flow capabilities, but this is now only for the Java module. What would be nice if we could describe some API that could be used in some other language modules to have some guidance how to implement this. And quick fixes. Yeah, some things we detect are really easy to fix, like missing curly braces or stuff like that. Or this broken null check could also be in the easy case, simple cases, fixed automatically. Then on the language side, right, we can start learning to use ANTLO correctly and create an abstract syntax tree. Maybe we could reuse some already existing. Then, yeah, what's anyway on the plate is keep up to date with Java, as there are now every 6 months a new version, which means we update our grammar, add some tests, make sure we can parse the new language constructs. And some other wild idea I had was some online version of PMD that just makes it easier to try it out, whether it's useful for you. This could even go to that direction that you say, I want to analyze this Maven dependency, see how it brings up, and just as a showcase or something like that. Right. That's now almost the end. So you got now maybe a first impression, maybe you knew already PMD before. I hope you got a good impression. And to help you remember, I have some stickers you can take with you. Yeah, so it's a static analysis tool, and as any static analysis tool, it's not perfect. It could have, it has definitely false positives, false negatives. But even if you use another tool already, you could still look at PMD, whether it detects some different kinds of errors, and add it as an additional safety layer maybe. And if it doesn't fit, it's open source, so you can contribute and and help to improve it. Yeah, and that's all. Thank you. Any questions?
Do you check PMD source code with PMD?
Yeah. We also check our source code with the snapshot version of PMD. Also the just built version checks in another run.
So currently you do not analyze any kind of Java mistakes in the versions above Java 8.
We can analyze code written in the latest Java version, so we support Java 23. But what we don't explicitly have is rules that basically search for misuse of new language constructs or something that could wrong. So the rules, they are maybe not really always up to date, but they can.
I mean, for those like years while we are using Java 8, the rules still were updated.
Yeah, so if we get a bug request, for example, we have some, for example, the switch statement with pattern matching. So there we got some bug reports that we have a rule that detects the default case, whether it's needed or not. And this logic didn't work anymore because we only, it's not an enum anymore. There are also other types, sealed classes and stuff like that. So these things will eventually pop up and get fixed.
And do you understand it correct that this Sonar Cloud is kind of your competitor, but enterprise?
Yeah, so Sonar is kind of competitor of this tool, so they do the same. In the past, I think they used PMD, but at some point they decided to rewrite all the rules on their own. So there's an open source plugin for Sonar that integrates PMD, but Sonar itself, by default, they don't use it anymore. And that's also where I took the presentation. More than 400 rules, more than 10 languages. That's the same thing what Sonar displays, how many stuff they support.
Do you support preview features as well?
Yeah.
So you actually go
So
up
we-
to date with the new Java.
Well, to be exact, we support parsing them.
Yes, that's the most important part. Of
Yeah.
this. So I mean, like you don't completely break if you encounter a new feature. Like
Yeah. But using preview features, it's a little bit more complicated because you need to have all the flags added to enable preview on every stage.
And like
But it's possible.
you have a single parser for all Java versions, or you have to set the Java version and then parse the Java file?
We have a single parser, and this, we basically, after we have parsed, we check which constructs are used, and if you use newer constructs that are not supposed to be supported, we fail with a parsing error.
I mean, sometimes depending on Java version, it's possible, I guess, to get like completely different parse tree. For example, before record was not a keyword, it was an identifier. So if you meet it, you should parse it completely differently.
Yes, this is, sometimes we do this.
So
So our parser is aware of the version of Java.
you actually need to get
And
Java version as an input.
yeah. So the parser itself knows about the version, but
Not the rule set.
no. But you can say a rule is only valid for a specific Java version, because at later versions,
It makes no sense for Java 4.
yeah, or in newer versions, there's already a solution for that. So it's or the rule suggests a solution that you shouldn't use today anymore.
And have you considered, especially during like major rewrite in Java 7, to use third-party engine? I know at least two. One of them is Spoon, another is Eclipse Java development tools, and I guess it's possible for either of them to use them as backend, providing like Java syntax and even like reference resolution, type inference, everything, so you can write your rules on top of that.
Yeah, I'm hesitating a little bit about Eclipse because I don't think that the PMD code is compilable with the Eclipse compiler. There are some, with generic, some minor differences in the implementation of the compiler, which makes the Java C original compiler work, but
No, but you
Eclipse,
don't need to compile it with Eclipse compiler. You can use JDT as a library.
yeah, but it still throws the same compiler error. At least if you want the bindings to the type resolution, it needs to do most of the stuff to actually
Yes.
resolve the types.
If you
Yeah,
have
but
models, you can just skip and like analyze further.
yeah, but we didn't really consider this, so we kept our own grammar basically.
And if I understood correctly, you don't like resolve references to other files, and you don't do type inference.
We do type inference. That's what we do. So you can ask for the type.
So if I have like an arbitrary Java expression, I can ask for the type of that expression.
Yeah, I'm not sure whether it works in all cases for expressions, but basically yes. So you can we can resolve the return type of method calls and stuff like that.
To do this, you actually need to load the
Right.
file where the is located.
So we do this by loading the class files. So you have to have your project compiled first, and then you run PMD with the so-called auxiliary class path, which contains all your project and all your dependencies. And in this class path, we search for the types.
Every source file you're analyzing, you actually have to have the class file as well.
Yeah, so you need to have your project compiled before.
Yes, and you need to supply like the whole class path for that project.
Yeah, so that's usually easier to use Maven or Gradle because they have the job to, for simple cases, you can run it on the command line,
So
but you need to create your class path, and that's the hardest part.
It means that you cannot do online analysis in IDE. I mean, type and you immediately see the warning. Because you need to have up-to-date compiled code.
You need to have the compiled code, yeah.
So in IDE plugin, you have to like explicitly launch the analysis to get the warnings.
Yeah, in Eclipse I know this, that's how it works. I don't know exactly how it works in the IntelliJ plugin, but I think it's explicitly launched in all cases.
I see. The rule editor, was it like standalone Java application or it's something or it's
That's
web-based?
actually a JavaFX app.
Oh, cool.
That once was a Swing app, and yeah,
As for
that's also something that we need to update because it uses some reflection part. So in some components.
JavaFX application could be challenging.
Yeah.
And as for number of like popularity of the project, I guess if some project uses PMD, it should mention PMD plugin and it's for maximum, at least
Yeah,
it's with Maven. Probably it's possible to query from Central, like number of public projects who use PMD.
Yeah, I think yes, that would be an idea to. You can see who uses this dependency.
Yes, and whether it's growing or not, something.
Yeah, you need to look it up for each version. I think you don't get an overview. No combined result. You need to click each version separately. Yeah.
And I'm also interested in code duplicates. Could you explain a little bit what as a user can expect from it? Like, does it work on Lexine level or it matches parts of IST? Like, I guess it's not like dark thing that matches on the streets.
No, it's
IST level.
It's on the level of the tokens. So we tokenize this, and we have some options to, for example, replace the identifiers, to ignore the identifier's name, the concrete name, so that it finds duplicated code even if the variable names are different. And yeah, it's based on tokens. The exact algorithm I can't tell you. I haven't written it.
Is it robust against comments? So if you have comments placed in different places, you will still consider it as a duplicate?
I think so, yes. So,
like sometimes, for example, I may have exactly the same code from the tokens point of view, but the types are different. Like, for example, mass.max for
the types.
Mass.max for long. Exactly the same method, but types are different, so we will be marked as duplicate.
I don't know. Maybe not. I think, yeah.
Okay.
But it's interesting that you mentioned whether it works on the AST. That's actually an idea of the one other maintainer, that he wanted to write this on the basis of the AST to compare subtrees, basically.
Yes, sometimes it could be even more robust because on IST you can do more normalization. For example, in one copy you have if statement without curly braces, and in another copy if statement with curly braces.
They look the same in the AST.
But I think if it's compiled, it's not so critical. Mostly those variable names, if they are local variable names, and braces. When it's compiled, I think you have only probably this. Just Java bytecode.
Well, bytecode would look the same. The idea is that you can actually find duplicate code to see if you can like extract common parts of it to make it better.
Yeah. So we analyze on the source code level. So in Spotbugs uses the bytecode to find bugs. We actually do analyze the source code, and we only use the bytecode for the type resolution to figure out, load the other types that are referenced. Yeah.
But I guess still, like the complete type resolution is really a complex thing. For example, like if you have lambda, you don't even have types of lambda arguments. Like, do you really can restore types of lambda arguments, for example? So if I'm writing a rule, can I query the type of lambda argument, for example, if it's not specified explicitly?
I don't know exactly, but we are probably not in every aspect complete on this front. But yeah, it's a complex topic, especially with generics involved.
It's the most complex part of Java language specification. I should have introduced myself earlier. Probably I'm from JetBrains, and I'm a team lead and technical lead in a Java team. So I'm working on Java language support, and yes, type inference is very complex thing, and reading it is like pure algebra. There is chapter 18 of Java language specification. It's not for weak people. So there are many corner cases, and IntelliJ works in corner cases a little bit different from Java C, and Java C works a little bit different from Eclipse. So all of us have incompatible bugs in this area. So, and I will be surprised if there is like another clean room implementation of this stuff, because it's like something really difficult.
Yeah, so it's I have to say it's not written by me. It's by one of the co-maintainers.
Probably I have to look
and
source code.
Yeah,
it's not like a question, just for discussion about long time maintaining of new version while keeping existing version working. We have similar story in Kotlin language. You might probably have heard that K2, which is like second language of Kotlin, is in development. It's already close to the release, and it also took, I don't know, probably 4 or 5 years, a lot, and huge team, like dozens of developers. So, and it's basically a complete rewrite of compiler, complete rewrite of backend. You have to rewrite most of inspections, most of refactorings, most of code completion, like everything. So, and at the same time, we have to ship working version of Kotlin. So, in fact, we had everything in one repo. So it was like just separate package, and you don't hesitate to copy paste a lot, because you know that at one point K1 will be dead and you will remove it. So at the end you will not have too much of copy paste. But in any case, it's not like separate branch. So if you want to reuse some code, you actually can do it. If you want to mass refactor, rename something, you can rename through K1.
Yeah, but you have 2 versions in parallel that can be used basically, and that
you can either build with K1 or build with K2.
Yeah.
When you are running tests, you actually have both plugins available, and you can, for example, run the same test for K1 and K2 and check like if both of them are working. So it's basically like feature knob, feature switch, branch switch, and I think it works better for like long-standing projects.
Yeah, I think so too.
But still, it's really painful. Like you have 2 things in parallel. Sometimes, like old version is broken. Sometimes new version is broken. Sometimes you don't want to fix old version because anyway it will die someday. So you don't want to waste your time. But new version is not ready, and people are using old version, and they complain that it's broken. It's hard.
You mentioned some bugs. What is out of mind right now? Do you remember some funny, interesting bug which is still not fixed?
Switch case.
No,
Do you have
not
problems
really.
with implicit classes? For us, it was like for some inspections, it was really unexpected. Like you suddenly have top-level declarations.
Yeah, we had some. So that's a still preview feature.
Yes. It's
Yeah.
preview, yes. It's not
Yeah, I think so before we didn't introduce a node, a class declaration node for this implicit thing, but some rule wanted to see the parent class declaration, which didn't exist. So
Expect that it has name
Yeah.
at least.
yeah.
Implicit classes, it's something like tuples?
No.
So that's one of the advantages you work on this Java thing and integrate the new versions. You know already the new stuff because you need to read the chaps and
It's like
get it working.
can declare, for example, main function at the top level without declaring class.
That's it? Only
It's-
for main function? Or
Not only you can declare other.
Yeah, it's basically, I think, to get started very simple, to not write public class main, public static void main, just to write void main. I think that's the simplest thing, just a method, and that's a valid Java program. So you can write void main, and there are some print statements now, some.
Plus files, which could be not classes, and they have contained methods, whatever.
Then you can add stuff, and only after a while you need a real class.
It's still limited, like you cannot refer to this file from other files because you have.
It
There is
yeah, it
still
has no
class
name.
methods
Yeah.
You cannot see it and you cannot qualify those methods because this class has no name. Yes. So it's only like for scripts or for learning Java. But for scripts it's really nice, I really use it like very small program to do some simple thing. Just don't declare class.
Okay, thank you, Andreas.